Hello everyone, so welcome to the final lecture of week 1. So in this lecture we will discuss about various NLP tasks and paradigms, mainly giving you an idea about what are different other tasks and paradigms that we have in NLP. So till now our focus mainly has been on language modeling. So in this lecture I will discuss briefly about other paradigms like text classification, sequence labeling, text generation and structure prediction, and give you some example of NLP tasks. So this we anyway covered in the very beginning of this week. So what happens in NLP? We typically take a problem and map it to one of the machine learning paradigm. So we do examples like sentiment analysis, news article grouping. They would come under text classification. Similarly, named entity recognition, code mixing, they would come under sequence labeling. Machine translation, summarization, chatbot, they would come under text generation. There is another very popular paradigm, so that is structure prediction, where whatever you are predicting has a structure, and we will see one example of that. And then we will see some different kind of NLP tasks, like they can be at the level of various granularity. So they can be at the word or span level. So for example, you are doing word sense disambiguation. For each word you want to find out what is the particular meaning that is implied. Entity linking, it can be based on a span. They can be sentence level tasks, like you are given two sentences and you have to find out how similar these are, or you want to say whether one sentence entails another or contradicts another. They can be paragraph or document level tasks like question answering and so on. So you can even have different kind of granularity over the tasks in NLP. And this lecture will give you a brief introduction to these, but not going into too much details. So let's start with classification paradigm, where we will spend most of the time, okay, because that is one of the more popular paradigm, and it also conveys a lot of different ideas about the task, method and the evaluation. So a very popular example from classification is sentiment analysis. So where you are given user generated data, maybe reviews, and you have to find out whether they are positive or negative. Like here you are seeing some examples of reviews, and you are told this is a positive review, negative review, positive review, negative. They can be movie reviews, can be review about a restaurant and so on, correct. So these are movie reviews and they are like restaurant reviews, and you have a plus and minus sentiment associated with that. Now sentiment analysis is a very important problem because there are many domains where you need that. So for example, you're talking about a movie, you want to know what are the public sentiment after the release of the movie. Is it getting positive reviews or negative reviews? Products, so whenever a new product is launched, an iPhone, what are user sentiment towards that? Politics, so given a candidate or a particular issue or policy of a government, what do people think about that? And also you may want to do prediction from say election outcomes and market trends and so on. So everywhere you need to know the sentiment of the people, and you can get the data from social media and do some analysis over that. And that's why this has become a very popular topic. So this was just an example for classification, right? So now, given that motivation, like what is the formal definition of a text classification problem? So your input is a document D, and by document I mean any unit of text, and typically this would be something like a sentence or a paragraph or a whole document. It can be a snippet of the user, it can be a particular review. So this is what we are calling it a document, and you want to classify into one of the predefined j classes C1 to Cj. This can be say positive, negative, neutral in case of sentiment analysis. So just 3 classes. So given this setting, you want to predict one class from here that correctly categorizes a document D. Right? That's the problem of text classification. Now, given this, in a supervised setup, you would need some label data. That what will be a label data in this case? Because given a piece of text you want to classify into one of these classes, you need some examples of this. So you need examples of, okay, this data D1 was classified into class C1, so on up to say DM classified into CM. So you have M hand labeled documents. So somebody has to manually annotate and say, okay, this is the correct category for this document and so on. And this is what you will need or you will use for developing your method. So your method will be a classifier gamma that will take a document and will predict a class for that. Okay. Now you could use any kind of classifier. It can be like very popular classifiers and naive classifier, support vector machines, neural networks, k nearest neighbors, and so on. So you can use any of these classifiers once you have this particular setting, right? And in this course, of course, we will focus more on the neural networks part. Especially, we will see how RNNs and transformer based models can be used for classification task in NLP. Okay. Now, given this, so how do you evaluate it, right? So for evaluation, consider a very specific scenario, right? So suppose you're doing binary text classification, and consider yourself as one of the CEO of Delicious Pie company, and you want to know what people are saying about your pies, right? So your company is already there, and people are tweeting about it. So you want to build a classifier that will just simply detect if an incoming tweet is about Delicious Pies, right? About your company, right? So you say, okay, so that means your input is any tweet that is coming at runtime. So input is a tweet, any tweet, right? And for you, the positive class are tweets that are about Delicious Pie company, and negative class are those that are at everything else is your negative class. Okay. So if a tweet talks about anything else, it's negative for you. Talks about Delicious Pie company, it's positive for you. So this is the detector you want to make. Okay. So now, how would you test? So suppose you make some model, and somebody says, oh, I would use naive model. Somebody else can say, I would use this model and that model. And then you have to say, okay, how would I choose which method to actually use, right? Somebody say, my method works with 99.99% accuracy. So should I just use that, right? So let's see, how would you choose this? So for that, you have to go to the confusion matrix, right? That typically is the way. So you have a binary classification task. So you have positive and negative classes. So there are some ground truth positive and negative classes, right? So assuming you have some data where you know these are my positive classes, these are my negative classes. And then the system can vary. So given a system, it will give something as positive, something as negative. So you can create a confusion matrix that is, okay, cases where system said positive and ground truth is positive, they are called true positive. Similarly, if system says negative, ground truth is negative, it's called true negatives. And then if the system says false, it's called false positive or negative depending on what the system said. So if the system said positive, it is false, it's called false positive. If the system said negative, it's false, it's called false negative. And then accordingly, you can define things like accuracy, that is how many cases you were correct, true positive plus true negative divided by everything else. What is your precision, how precise you were. So you called positive these many cases, only here you were correct. So precision is true positive divided by true positive plus false positive, and so on. That's how you can define your matrix. Recall would be among how many things that were positive in ground truth, your system would recall. So among all of these, it could recall this many. So TP divided by TP plus Fn. So that's how you could define various metrics. The question is, can I not simply use accuracy? Why do I need this precision recall? So let's take a scenario. So suppose we have 1 million tweets, and out of those 100 talk about Delicious Pie company, right? And remaining 9999900, right? 0.9999 million tweets talk about something else. Now somebody can give you a dumb classifier that says everything, every tweet you give its input, it says it's not about Delicious Pie Company, right? What would be the accuracy of such a system? So it will say, okay, out of 1 million, in 999900 cases it will work correctly out of 1 million, right? So its accuracy will be 99.99%. Right? But is that useful at all? So every tweet you are taking, it is saying it's not about Delicious Pie. So it is not giving you any tweet to further analyze, right? So it's completely useless for you, right? So that's why accuracy is not a very standard metric always for classification. So we focus on precision and recall. So you go back and see what is the recall of the system. So the recall of the system would be, so you are not retrieving any tweet about Delicious Pie. So 0 divided by something. So recall will be 0, and you can immediately discard this particular method, right? You can't talk about precision as such because it's not giving you any Delicious Pie, so precision is not even defined for this case. So recall would be 0. Okay, so recall becomes 0, so it does not give you any of these pies, right? So that's why precision recall are important, because they emphasize on true positives, right? So finding things that we are actually looking for. Now precision recall are two different measures. People also have tried to combine them, and that is typically one of the better metric, that is F measure. So you could also give a weightage to precision recall with beta term, but typically beta is equal to 1 is used by default. So you have a harmonic mean of precision recall, that is the F1 measure. Okay, so let's take a quick example on what if you have more than 2 classes. Let's say you have 3 classes. So you are doing this email classification task into urgent, normal, and spam. So this is your ground truth and system output. So you can again create a confusion matrix, right? Creating confusion matrix is very easy. You have the ground truth labels, you have the system labels, and you can just see given how many are both urgent and so on, right? So you can very easily create this confusion matrix. And now precision recall are defined very similarly to what we saw earlier. So what is the precision of, say, class urgent? So you say, okay, 19 cases my system called is urgent, out of which only 8 are correct. So precision is 8 by 19 for urgent class. Like similarly, say what is the recall for the class spam? So there were 251 spams, out of which my system recalled 200 of those. So the recall for spam is 200 by 251. Like that you can verify the other values, right? Okay. Now the question is fine. So now I would, if I have more than 2 classes, the binary class we are only interested in the positive class precision recall, so it is easy. But when we have more than 2 classes, then different precision and recall measures are coming into play. So then is there a single metric that I can use, right? So otherwise we have to work with so many different metrics and difficult to evaluate if one system works better on one precision versus another precision, right? So can I combine them into a single metric? So there are 2 ways to do that. One is macro averaging, second is micro averaging. So macro averaging, what you do, you will compute the values for each class first and then average them. So it gives you equal weightage for each class, right? In micro averaging, what you will do, you will collect decisions for each class, combine to a single confusion matrix, and then you will compute precision recall from that table, right? So that's the difference. So let's take a quick example. So let's say we have the previous table itself, from which what we do, so we can combine the results into a single matrix to make it look like a binary classification. So if you recall, so this was our matrix. So I want to combine this into a single binary matrix for urgent class. I'll say, okay, urgent, urgent, not urgent, not urgent. So, urgent remains 8. Now, urgent not urgent will be 10 plus 1 11. Urgent non urgent here will be 5 plus 3 8, and remaining this will be right 340. Yeah, 340. So, this will become the corresponding matrix. So, and now from there you can say okay, the precision will be 8 by 19, recall will be 8 by 16, right. You get back the same values that you were getting here. Okay. So, like that you combine into single matrices. Now, you have the precision for each from each of these. So, macro what you will do, you will just take an average of these. So, I will take an average of 0.42, 0.52, 0.86, I get 0.6. For micro averaged, what I will do, I will combine all the decisions into a single matrix now. So, I will have what is the true positive 8 plus 60 plus 200, 268. What is true negative 340 plus 212 plus 83. So, like that I will combine here, and then I will compute the precision of this. So, precision will be 268 divided by 268 plus 99. Right. So, that will be the precision 0.73, and you see they are not like very close to each other, right. And why is that? Because macro average precision gives equal importance to each class, right. So, it is giving an equal importance to each class, while micro average precision is not doing that. It will give a higher weightage to the class that has more instances. In this case, spam has more instances, and that is why it is more biased towards spam, while here it is just taking an average value across all. So, when you have imbalanced data set, when the classes are not properly balanced, it is preferable to use a macro average precision. That will give you a much better idea about the system. Otherwise, which may be doing good only for 1 or 2 classes, may not be performing well for other classes, which are also known as the tail classes, where you do not have sufficient training data, not sufficient training data. Okay. So, now given this idea about classification, let us move on to other paradigms more quickly. So, next we talk about sequence labeling paradigm. So, what is the problem here? So, now you are given a sequence and you will label each word in the sequence by some class, right. Rather than labeling the entire sequence by one class, each word in the sequence will be labeled. Now, examples we gave was like named entity recognition, code mixing, and we will take one example here, that is part of speech tagging. It is one of the very famous grammatical tasks, and very early like Indian grammarians like Yaska and Panini in their linguistic treatise, they have mentioned about the categories that the words typically have, and in various other traditions also it was mentioned. So, so we also know them from part of speech, word classes, and so on. Now, 8 parts of the speech are very common. For example, noun, verb, pronoun, preposition, adverb, conjunction, participle, and article. They are like in this diagnosis flux it was mentioned, and they are still now very popular classes for understanding grammatical categories of various English words. Now, there are various different tagging schemes that are there that have given various part of speech tags. Okay. Now, one thing that they help us in understanding that some of these categories are open and some of these are closed. Right. So, closed class will be the things that are already fixed. So, we already have a fixed number of determiners, conjunction and pronouns, and we don't create these new determiners and pronouns every day, right. Same with prepositions, particles, and so on. But there are some that are open class, like nouns. There are as many proper nouns that as you want, right. You can have new names, you can coin new words, right. And so, all proper nouns, common nouns are there. Verbs, main verbs and auxiliary verbs. Auxiliary verbs are closed class, but main verbs are not. And then you have numbers and adjectives, adverbs, and so on. So, you can also do this kind of division between open class versus closed class, right. Closed class are typically function words, right. They will try to bind the sentence together, while open class words are typically talking about the topic of the conversation or the sentence. Okay. So, what is this problem of part of speech tagging? So, the problem is that you have to assign a part of speech to each word in the text, right, and it becomes difficult because there are words that will have more than one part of speech, right. I will just give an example like the word book, right. Simple word like book, it can be a verb like book the flight, or a noun like hand me that book. So, that means this is again a disambiguation problem. Given a word, a sentence where you have the word book, whether it's a noun or a verb, and that's the problem you have to solve for many different all the possible words in the English or any other language that you are dealing with, right. So, like for English, Pantry Bank is very popular, that has a good text set, around 45 texts are there, and you can go through that. I mean, there are like cardinal numbers has a different text set, adverbs are there, and there are foreign words and so on, different kind of text sets, and there are separate text set for different type of noun like proper noun and plural noun and so on. Okay. Now, how do you solve these sequence labeling problem? Like classical methods were like hidden Markov models, maximum entropy Markov models, conditional random fields, and the more recent methods are more on RNNs, LSTMs, and transformers. Okay, and while these are covered in a typical NLP course, in this course we will talk about how these methods like RNNs, transformers will be used for sequence labeling. And to evaluate, again this is very similar to classification, except that now you have at every word label you have a ground truth and a corresponding system output. So, accordingly you can do accuracy and F1 score. So, if you do macro F1, you will give equal importance to each part of speech tag here in this case. Okay. Now, let us move on to text generation paradigm. So, I will take a quick example from dialogues. So, in dialogues we want to generate response, right. So, you are given some context in utterance and you have to generate one response, and the idea is that you want something that is consistent, coherent with the current history of the dialogue. Should also be interesting and engaging, and you should progress it towards one particular goal. Okay. So, there are two kinds of conversational agents that we have. So, we have chatbots that you are just conversing, I mean for fun, or sometimes even for therapy, and then there are dialogue agents that are like doing a specific task like booking hotel for you, take flights for you, and maybe some appliances from which you are conversing to get something done, right. So, these are typically two kind of conversation agents, and architectures are again like rule based methods. So, these were the very early models like Elijah and Perry, and they in some their own sense they were able to even pass the Turing test. So, but they were based on very simple rule based methods, and this had some mental model. And now recently there are more models on retrieving things, like you can retrieve the possible responses. So, show each one possible architecture, and now what has been the most prevalent is the encoder decoder based architecture like Blunderbot. Okay. And our focus in this lecture will be more towards this. We may discuss a little bit on this, but we will focus more on neural encoder decoder kind of architecture. So, just to give an idea of how they will work. So, you have to think about your entire previous context as the history, the query, and you want to generate a response, right. So, you can think of it as if you are generating response one word at a time, right. And now, when you say generating one word at a time, it looks like a language model, except that it is conditioned on what has happened before, right. So, you condition your generation based on the query, that is whatever has happened before, plus whatever you have actually generated till now, right. So, this is why it is called it is also known popularly as conditional language model. So, a particular condition, but you are still generating one word at a time based on that condition. And you would see other methods like machine translation models also come under the same category, where your previous condition, the sentence, input sentence, you want to generate the output condition on that. So, it is also a conditional language model. Now, the evaluation here is a bit more tricky than the previous two paradigms, because you may not have a single valid response all the time. So you can say hello, you can say welcome. I mean, there are many ways you can respond to a dialogue. Now, how do you know which one is the correct one? So that's why there are many specific nuances on evaluation. We will discuss that, right? But one thing is that in this generation, human evaluation is very crucial. So you typically also try to get some human evaluation done, right? So that you have better idea whether the system is really usable, it is doing something important and relevant to the particular task that you wanted to do. Okay. Briefly about structured prediction. So here's an example like dependency parsing. So you are given a sentence, you find out how the words are connected to each other through grammatical relations. So this is very similar to the Karaka relations that we read in our textbooks. So for example, you have a sentence which has words W1 to Wn. You want to find out what is the relation between them. So you are saying, for example, the word head is the root and its subject is news, its object is effect, and its noun modifier is little, and so on, right? Markets has a noun modifier financial. So you are finding relation between words, and that tells you the entire idea about the sentence, how the words are connected to each other in various relations. So this is dependency parsing, and because you are trying to generate a graph at the output, it's a structure that you are generating, right? It's not similar to the previous paradigms. It's a structure you want to generate, and that's why it's a structure prediction paradigm. There are various things, even you generate constituency parsing. That will also come under the same paradigm. Semantic role labeling, that will also come under the same paradigm. And they have their own evaluation metric depending on what is the structure you are generating, because you have to evaluate the structure also, like here whether you have generated the relations correctly and whether the labels are correctly. So you have unlabeled attachment score and labeled attachment score. There are two different kind of evaluations that you use for dependency parsing. Okay. Now, given these paradigms, let's see some examples of NLP tasks at different labels, but very short. So at a word label, one task is like word sense disambiguation. So where a word may have multiple meanings, but depending on the context, you want to find out what is the correct meaning. Like the example of this word, is it bass in the music or bass in the case of say fish, right? So when you read a sentence, you can immediately get that, okay, electrical guitar and bass player. So you say, okay, this is the musical sense, striped bass in the lake. So it is a fish sense, right? But what is the general method by which, given a word, you can find out the correct sense of that? So the task is that which of the senses of an ambiguous word is invoked in a particular use of a word, and looking at the word's context, I can find that out. Entity linking, another such problem where you are given some document and your task is to find out what are the entities that are of relevance and link it to some other knowledge base. Like think about linking it to Wikipedia. So you are writing a Wikipedia article, but this entity is already there on the Wikipedia. So you will give a link to its corresponding Wikipedia article, right? You can think of it like that. It can have challenges because there would be again ambiguities. The same entity may have occurred as like names can be name of a president, of a sports person, of a professor, and so on, right? So which one would it link to? So it will have the same disambiguation problem. Now let's go to a sentence level task, like finding out how much these two sentences are similar. I am taking an example from Quora question pairs. So it has around 400,000 question pairs, and each question pair has an annotation. Is it duplicate or not? Because in Quora, as you know what happens, people ask questions, and sometimes the same question may be asked as a paraphrase, right? So you don't want to answer it again, but to say, okay, this question is already answered before, you can read the answers, right? So what are natural numbers? What is the least natural number? and the label is, it's not a duplicate. I mean, there are two different answers. But how do you start a bakery and how can one start a bakery business are duplicate questions. The answer for this will suffice here. So the task is 2 sentences, whether they are similar or not, right? And you can read more about this data set. Similarly, a more involved like paragraph or document level task is question answering. So here I am taking an example from a SQUAD, the Stanford question answering data set, where you are, it's like a reading comprehension task. You are given a paragraph and your question is like who ruled the Duchy of Normandy, and they took multiple annotations by people. So they have labeled as spans in the paragraph that answer that question. So, and there are also questions that do not have answers in the paragraph. Okay. So this is the SQUAD 2.0 version, and then you have to really find the answer and do various evaluation to see how close you are to the ground truth answers. So yeah, I mean, and there are like lots and lots of data set benchmarks of on NLP. If and I would recommend you to go through this resource that is free. So you can go to Papers with Code website, and you can click on this text data set, and you click on this text, and you will find it like as of today I am seeing 2,892 data sets about text. So you can and you will anyway have them sorted as per which ones are more popular and how many papers are using these data sets. And you can see lots of examples of the kind of NLP tasks that have been popular in the recent years, right? And this would help you get started. Okay, so with that we end our week 1. In week 2 we will start more about deep learning basics. So we will give you the deep learning basics before going into the deep learning for NLP. So this week again, this week you can go through this speech and language processing book. Also, many of things are covered in the NLP and NPTEL course that I have taken here very short. Okay, thank you.